Welcome back, everyone. Before we talk about the last two types of chemical reactions based upon chemistry, which will be gas evolution and acid-base reactions, before we talk about those, I just wanted to revisit this slide that summarizes the categories of chemical reactions we've discussed and some of the terms. When we discuss about what atoms do during a reaction, we can talk about that reaction in terms of a synthesis reaction. So for example, if I take two simple substances and combine them, that's a synthesis reaction, if I can say that properly. Breaking that product down into its simpler substances is a decomposition reaction. In single displacement reactions, you have the cation, or you have a cation from one switching places with the cation from another. And in a double displacement reaction, everyone switches partners. So in this example, AB plus CD, the cation from one species pairs with the anion of the other species. Okay. So that's based upon what atoms do during the reaction. We can also classify based upon their chemistry. We said that all precipitation reactions are reactions where a solid is produced. Most of the precipitation reactions we are going to talk about in this class are going to also be classified as double displacement reactions. When predicting the products of a double displacement reaction, if one of these products is a solid, then it would be also classified as a precipitation reaction. Oxidation reduction reactions, those are chemical reactions that deal with the transfer of electrons. In that reaction, something is oxidized, something loses electrons, and a different species in that reaction gains the electrons or is reduced. So we said one way to remember that is Leo goes Gur. Losing electrons is oxidation, gaining electrons is reduction. And we said that combustion reactions are a type of oxidation reduction reactions. Single displacement reactions can also be classified as an oxidation reduction reactions. You saw that in your experiment 7 redox experiment. So the point I'm trying to make in this slide, aside from reviewing, is to show you that many times a reaction can be classified in more than one way. You can have a single displacement reaction also be an oxidation reduction reaction. So you should feel comfortable being able to classify a chemical equation in more than one way. But for now, we're going to go on to gas evolution reactions. So in gas evolution reactions, you can imagine that in gas evolution reactions, you're always going to have a product that is a gas. Okay? And in the gas evolution reactions that we will deal with, they are mainly, in fact, I think most of them are going to be double displacement reactions. So you'll use your double displacement skills to predict the products. And then if one of them is a gas, then it's a gas evolution reaction. Okay, that's great. You may say, you know if something is a solid by using the solubility rules, but how do you know if a product is a gas? That's where this chart is going to be handy. And you don't need to memorize it because I told you could use your PowerPoints, these PowerPoints for the exam, but that star should tell you that this is sort of important, that if in a double displacement reaction, you produce an intermediate, you have a reactant type that is one of these, and you produce an intermediate product, then that intermediate product will decompose to give you the gas listed. So, for example, let's look at this reaction right here. And I know I have the products written already, but let's go ahead and talk about how those products were predicted and how I knew that this was going to be a gas. So I have sulfuric acid aqueous reacting with lithium sulfide, aqueous. And I have to predict the products. Should realize that, oh, I have something that is a sulfide. I have something that is a sulfide. So I know that one of my products is going to be hydrosulfuric acid. That is a gas. You could know that from the chart, but you could also determine it by doing our little crisscross to predict the products and then use this chart to determine if it's a gas or not. So let's take these two reactants and just to practice our double displacement skills, do our little crisscross and see, well, how did I come up with hydrosulfuric acid and lithium sulfate as my products? So we're going to do double displacement with this. So cation and anion of one, cation and anion of the second reactant, and do the crisscross. So for sulfuric acid, what is the cation for sulfuric acid? Well, the cation is hydrogen. It's not H2. Remember that 2 is there to balance the charge. It's just hydrogen, and hydrogen in group 1 plus 1. What is the anion? The anion, oh, it's a polyatomic, sulfate. And sulfate, that's one of the ones you had to memorize, -2. So that's the cation and the anion of my first species. Now let's do the cation and anion of the second species. My cation is lithium, not Li2. Again, that 2 is there to balance the charge. Just Li. Lithium's in group 1, so plus 1. The anion, sulfur. And sulfur, it's in the same group as oxygen, so group 6, so -2. So now I have set up my little crisscross with my cation and anion for each. And when I do the crisscross, I can see that the hydrogen is going to pair with the sulfur. And since hydrogen's a +1, sulfur is a -2, I need to have 2 hydrogens. So H2, subscript 2s. And I know this is a gas from the chart. Plus, lithium pairs with the sulfate. And since lithium is a +1, sulfur is a -2, that means I need to have 2 lithiums. So Li2SO4. And from the solubility rules, you can determine that that is aqueous. Okay? So not only is this a gas evolution reaction, but it is also a double displacement reaction. Okay? Last point to make about this slide is that gas evolution reactions are usually produce their gas because their intermediate product is unstable. Now, in the case of the sulfides, you don't have an intermediate product. You just produce H2S. But for these others, if you have a reactant type that is classified as one of these 3, then when you do your double displacement reaction, you're going to get one of these intermediate products, either carbonic acid, sulfurous acid, or ammonium hydroxide. That intermediate product will decompose to give you the gas that is listed. And you can see just by looking at the intermediate product and the gas that's evolved that something else has to be left as well. Remember, number and type of atom on the left has to equal number of type of atom on the right. So for carbonic acid, if that's going to break down to give me CO2 gas, what's going to be left? I'm going to have 2 hydrogens and 1 oxygen left. So specifically what's going to be left is liquid water. Okay? So for the carbonates and the bicarbonates, along with the sulfites and bisulfites and ammonium, the gas that is evolved is the one that's listed here, but you are also going to produce in your reaction liquid water. So I believe that there is an example in the worksheet where one of your intermediate products is sulfurous acid, and then that will break down in your molecular equation to give you SO2 gas and liquid water. Okay. So gas evolution reactions have a gas as a final product. They are a subset of double displacement reactions.